Good day, guys. Today I'm going to share with you a sample procedure in differentiating a function using increment. It is hoped then that everyone must be attentive enough for this presentation. Okay, let's go. Okay, so here is one sample problem that I can show you in finding the derivative of y with respect to x in terms of increments. Okay, so the equation is y equal to 3x squared plus 5. So initially, the first thing that you are going to consider will be changing your y into the form y plus change of y, and then for x here into x plus change of x. Okay, now so since the equation is 3x squared plus 5 as your independent variables, so the equation now looks like this: y plus change of y, which is equal to 3, that one, change x plus change of x, referring to the x here, squared plus 5. The next thing is that we are going to transpose y at the other side of the equation. So it will now look like this: change of y is equal to 3x plus change of x squared plus 5 minus y. So the y there is already here. After that, then expand this. So 3, expanding this one, we have x squared plus 2x change of x plus change of x raised to 2, that one, plus 5, and then substituting the value of y here. Look at this. Y is equal to 3x plus 5. So substituting that value, we have minus 3x squared plus 5. Okay. Next thing to do is that, of course, we need to simplify this one. Removing the parentheses and including now the 3 factor of 3 here, we have 3x squared plus 6x change of x plus 3 change of x squared plus 5 minus 3x squared minus 5. Okay. Next step is to cancel terms that are similar. So what are they? What are these? We have 3x squared here and then minus 3x squared there. We can cancel it out. We can cancel this one out. And then the other one is here. 5 and negative 5 can be cancelled out. So what remains now will be change of y, which is equal to 6x change of x plus 3 change of x squared. The next thing to do is to factor out common factors, of course, and that will be your change of y, which is equal to what? So notice that change of x and change of x at the other side. So you could bring it out, change of x. What remains now here is your 6x plus 3 change of x, since we still have 1 remaining there as change of x. And then divide this one by change of x, both sides of the equation there. Then after that, once we have already divided this one by change of x, then we can cancel this out, change of x. And then next, we have your change of x. Let me erase this one portion here. Okay. Change of y with respect to change of x is equal now to the limit of the remaining term. Limit of 6 of x plus 3 change of x when change of x approaches 0. Okay, so when limit of 6 of x plus 3 change of x, where change of x approaches 0, naturally, change of x will now become what? Okay, I will just write it first here, no? Change of x is equal to limit of 6 plus 3 change of x when change of x approaches 0. So if change of x approaches 0, therefore that is already 0. Therefore, change of y with respect to change of x will now become 6x, by which change of y with respect to change of x is also known as the derivative of y with respect to x equal to 6x. This is our final answer. Okay. So that is now the equation. Y is equal to 3x squared plus 5, and then determining the dy dx using increment. Then this is the process. Dy dx now turned out to be 6x. This is our answer. Now, that again, may I just try to have a summary of what we have presented, such that if we have given up the function y is equal to 3x squared plus 5, first, you have to change the y into y plus change of x, and then x for x plus change of x. And then apply the process, change of y, transpose y at the other side. That is why from plus, positive, then this turned out to be negative because we are transposing it at the other side. Then here, expansion of binomial. So here, so x squared plus 2x change of x plus change of x squared. We just erase the other factors here, 5 and so on. Simplifying this one, and then factor out change of x, and then divide change of x, both sides, cancel terms needed to be canceled out, and then after that, take the limit of the given function when change of x approaches 0. When change of x approaches 0, then naturally all the change of x's there should be turned out to be 0 because change of x approaches 0. And then the change of y with respect to change of x now would be the final term remaining, and that within dy dx, which is equal to the final answer. So that's it. Thank you, guys. Okay, guys, now I have another example for you in determining the derivative of a certain function applying increments. So on the board you can see the function of y, which is equal to x all over x plus 1. Now, if we are going to find for the derivative of y with respect to x using increment, then the first thing that you are going to consider will be changing your y into y plus change of y, your x into x plus change of x. Again, for x plus change of x, of course there's still a factor of 1 there. Next, you have to transpose the y at the other side of the equation, so that this will now become x plus change of x. We have x plus change of x plus 1 minus y. Okay. What's next? We are going to simplify this one so that the value of y later will be change it to its corresponding value. So we have change of x plus 1, and then this time your y now will be changed it into x all over x plus 1. Now, since it involves here fractions, so what shall we do with this? We have to find for the least common denominator. But unfortunately, we cannot just simply have a numerical value for this as your LCD, but instead, better for us to copy both factors like this. Okay, so you have x plus change of x plus 1 multiplied by x plus 1. When we divide this term divided by this side, what remains now will be x plus 1. So the factor x plus change of x will still be multiplied by a factor of x plus 1. Minus, so minus here, x plus change of x plus 1 multiplied by x plus 1 divided by x will give us x plus 1, I should say will give us what? The factor here, x plus change of x. So we have x plus change of x. So we have x change of x plus 1. Okay, there. So what next now is that we are going to distribute or multiply this one using the distributive property of multiplication. So we have change of y is equal now to there. So x and x will now be having x squared, then x and 1 there should be plus x, then this one is plus x here, change of x, then here change of x plus, okay, multiplied by 1 is change of x, that one, and then minus values here, okay, distribute. So we have x squared minus x change of x minus x. I will just remove now the parentheses. So x squared minus x change of x minus x. Same denominator, we have x plus change of x plus 1, and then we have x plus 1. Okay. Next step, we are going to simplify this one. What shall we do next? We can cancel out x squared with x squared. Plus x minus x. We have x change of x, we have minus x change of x. What remains now will just be the change of x. So therefore, change of y is equal now to change of x all over x plus change of x plus 1 multiplied by x. I'm sorry, this should supposed to be again x plus 1. I always saying x minus 1 for x plus 1. There. It's good that there's no such change no with the value there. Okay. Yes. So with the other one. Okay. So we have change of y is equal to change of x, x plus change of x plus 1, x plus 1. Next step, change of y, divide both sides by change of x. So we have denominator of change of x but we divide both sides by change of x, we have like this, x plus change of x plus 1 divided by x plus 1. Now we can cancel out these terms, so that when change of y, change of x, the limit of this function now 1 all over x plus change of x plus 1, and then the x plus 1 here, such that your change of x approaches 0. You notice that change of x here cancels out there when that is equal to 0. Therefore, change of y all over change of x will now be equal to 1 all over x plus 1, x plus 1, or simply dy dx, which is equal to dy dx, will be equal to 1 all over x plus 1 squared. That is the final answer. 1 all over x plus 1. Okay, so that will be the solution that I could share with you guys. Hope you're able to comprehend with the presentation of this problem together with the solution. Thank you. Let me give you a clear view with the final answer of the solution and income of the value change of y with respect to change of x. So here is now the additional numbers of the solution, such that from the given value we have this one. The given function y is equal to x divided by x plus 1, where we're coming out with a value change of y with respect to change of x from the given. And then applying the procedure in differentiating the function, we arrive at this change of y with the change of x when the limit of function approaches 0. When this function of change of x approaches 0, then naturally change of x is 0, and then as such change of x cancels out, resulting the change of y with respect to change of x is equal to 1 divided by x plus 1 multiplied by the quantity x plus 1. Therefore, the final answer will be change of y divided by change of x is equal to 1 divided by the quantity x plus 1 squared. Okay.